every series of hydrogen spectrum has an upper and lower limit in wavelength. The spectral series, which has an upper limit of wavelength equal to 18,752 angstrom is, where Rydberg constant is given. Balmer, Lyman, Paschen and Fund are the options. Now, we can use the formula 1 by lambda, that is wave number, into Rydberg constant 1 by n1 square. This is where it will end 1 by n2 square. Okay. Now, upper limit, series limit means the transition, series limit means that is the lowest wavelength, so that is also called series limit. Then the transition should be from n1 should be infinity, n2 can be 1, 2, 3 like that, 1 for Lyman series, 2 for Balmer series, 3 for Paschen, 4 for bracket, 5 for Fund. That is the lowest wavelength. That is lowest wavelength. Highest wavelength is called upper limit. That is, if n1 is 1, n2 should be 2. If n1 is 2, n2 should be 3. If n1 is 3, n2 should be 4, like that. Like that it takes place. Now, what we will calculate is the ratio of 1 by n1 square minus 1 by n2 square. For how much it will equal, that we have to see. So, what we will do is 1 by lambda r is equal to 1 by n1 square minus 1 by n2 square. That is 1 by 18,752 into 10 to the power minus 10 angstrom. Rydberg constant is given to you 1.097 into 10 to the power plus 7 per meter is equal to 1 by n1 square minus 1 by n2 square. The answer that you are going to get here is 7 by 144, which is 1 by n1 square minus 1 by n2 square. Now, if you look at the fractions, of 1 by n1 square minus 1 by n2 square, and this is 144. You can think of many, but there must be a difference. So, this is now looking at this 44 and all, if you go on substituting the values, you are going to get n1 equal to 3 and n2 equal to 4. If n1 is 3, it is a third series. Third series is Paschen series. So option C is the right answer. Option C is the right answer.